This talk is about the why of conservation. I meet many people involved in conservation who may be doing things like setting up protected areas, managing protected areas, national parks, harmonizing conservation protocols, many things like that. But all of these things move towards one end, which is the prevention of extinction and the reduction of biodiversity loss. Yet what does this mean in the big picture? So this talk is going to be about the meaning of conservation in the big picture. And the big picture I'm talking about, there are many big pictures: a social picture, a political picture, a religious picture, a philosophical picture. The big picture I'm talking about is the big picture afforded by evolution, the picture in deep time. Biodiversity, as you know, has many faces. For me, as an orchid fancier, it represents the vastness of species out there that I'm trying to find out about. And biodiversity loss and extinction, which I fear, is the loss of some of these. But can we be a bit more scientific? Biodiversity can be described in many different ways. There's taxonomic, functional, genetic biodiversity. And there are many different levels of biodiversity. We can talk about species, we can talk about genera, families, and so on. I'll stick with a simple one today in this talk. It's just the number of species in some area. And thus, the extinction of a number of species reduces the biodiversity by that number. And there's a lot of biodiversity out there, and we've described about 1 to 1.9 million species. You might think it's strange we don't know the exact number, but remember that all these descriptions reside in collections and databases and museums that are not necessarily connected with each other. And so bringing all these together and into harmony is a big work in progress. And the number we've described is only a fraction of the total. But we've been getting better at estimating what this total that we haven't described is. For many years, it was anything between 3 million and 300 million species. But in recent years, we have arrived at something more like 5 million to 15 million. This study cites a number of 8.75 million. But for this talk, I will use the number of 10 million, an easy number. And that 10 million is only 3% of all the species that have been since the Cambrian. So for every species that's in existence today, there are 30 extinct species. Now, since that Cambrian period, biodiversity has been increasing gradually. Slowly and gradually over the 600 million years since the Cambrian, it's been increasing. But there have been these episodes of extinction where the biodiversity on Earth decreases. These red arrows showing those. And there are lots of other episodes of extinction too. So we can see that extinction is a very important part of the evolution of life on Earth. Indeed, extinction, far from being an aberration, extinction is the forge of biodiversity. There could be no biodiversity without extinction. Extinction appears sometimes to be the dark side of evolution. But extinction opens space for new species. You could think of an initial community which is very small, and new species are created, so that you now have a full community, a saturated community, into which it's very difficult for new species to arrive. But then extinctions happen and open up spaces again in the environment, which allows new species to come in, and on this biodiversity cycle goes through the ages. So extinction is an essential part of evolution. And if we look at the fossil record, we arrive at Van Valen's law, which says something about the length of time species stay on Earth before going extinct. In fact, it's more or less constant that species hang around for about 10 million years and then go extinct. So if you think of that, 10 million years per species, and we know that there's around 10 million species on Earth, that means that on average, the background rate of extinction is 1 species per year globally. Globally, species go extinct at a rate of around 1 species per year. And we can see some of these examples. 2 examples of natural extinction in the modern era are given here. One went extinct when an epidemic wiped out its natural habitat, and another went extinct in the Great El Nino of 1982. In neither case were these events particularly anthropogenically caused, so we don't have major reasons to believe that these are human-caused extinctions in disguise. But humans, definitely, we have been causing extinction. And this began in the prehistoric times. It used to be thought that all extinctions that happened in prehistoric times were natural and happened due to things like climatic change. But we've been learning that many of the extinctions that have happened in prehistoric times were caused by us. For example, take the arrival of humans in the Americas, which happened around 12,000 years ago. As the Clovis culture entered North America via the Bering Strait, humans very quickly spread across North America and then into South America. And as they did so, the evidence suggests that a wave of extinctions followed, probably due to the improved hunting techniques that were being applied. So sudden was this often called blitzkrieg of extinctions, that within a few hundred years of the arrival of humans in North America, most of the megafauna of North and South America was extinct. Things like mastodons, mammoths, saber-toothed tigers, and so on. Similar events happened in Australia and New Zealand. Thus, many prehistoric animals can be found that went extinct because of human intervention. All of these great animals here were the victims of human interference, direct or indirect. Of course, this was the prehistoric times, and people didn't really know what we were up to, and you can hardly blame people because of the difficulty of life at the time. But one of the things about conservation biology is that it puts us in mind of these sort of things so that we can forestall such things happening in the future. so that our descendants won't look back on our time and say, oh, if only those people in the 20th and the 21st century had been a little more careful, we'd have things like elephants, lions, tigers, and bears in the world today. So this is one of the purposes of conservation, is to forestall such future extinction events. But people in prehistoric times may not have known, but into the historic period, humans were starting to understand the meaning of extinction. And so we have records of many of the species that went extinct because of our interference, such as the dodo, the quagga, the Tasmanian wolf, and many others. Most of those extinctions in historic times were due to things like overhunting or introduced species, especially cats, rats, and pigs. But nowadays, we also have to worry about habitat loss and climate change. And if you go through the IUCN Red List, you can find examples of all of these mechanisms of extinction in recent times. But probably the main agent of anthropogenic extinction today is habitat loss. So if we want to put human-generated extinction into the big picture and see where does our interference fit, given that things do go extinct, we have to look at habitat loss. And how do we do this? Well, there is a relation in ecology called the species-area relationship, which is one of the most established things in ecology. And it basically says something that is intuitively simple, but needs to be shown. And this is saying that the number of species that can be supported in large areas is bigger than that in small areas. So, for example, this picture is of birds on islands in the Southwest Pacific. And as you can see, for smaller islands here, the number of species is small. But for big islands, ones with large areas, you can support more species, you find more species. So, bigger areas mean more species. But the converse is also true. Smaller areas support less biodiversity. And if we have a region or an island or some habitat that loses area, then the number of species therein must also decrease. Extinctions must happen. And we can use this species-area relationship, we usually use the Arrhenius species-area relationship, to estimate how many species we lose if we lose a certain amount of area. I've gone through this calculation for species loss in the Amazon. And I'm not going to say much about the actual calculations. I've used the species area relationship here. And I've used data from the year 2010, because rates of deforestation and so on change from year to year. But it gives an answer of 3,000 species per year. So what does this mean? Well, the natural rate of extinction is 1 species per year globally. And the anthropogenic rate, due to habitat loss in the Amazon alone, is 3,000 species per year. So this means that the overall anthropogenic rate must be much greater than 3,000 times above the background extinction rate for the planet. This is too much. These rates of extinction are far too great for the planet to sustain. And thus, we need to do conservation. Extinction is necessary on an evolutionary time scale. It's the process which creates biodiversity. But we've always agreed that it's a bad thing on human time scales, and certainly when we see these kind of biodiversity loss rates. We don't really know when conservation began, but it must have begun at least as far back as the Paleolithic, in some de facto form. For we see that there was coexistence between humans and animals such as mammoths, cave lions, other predators for many thousands of years. Contrast that with what happened in the Americas when Clovis people invaded. Nevertheless, the mechanisms of conservation in this Paleolithic time are not known. As we go into historic times, we can see examples of traditional forms of conservation, such as sacred natural sites. And so in the modern era, conservation has evolved further. And conservation, which began in the 17th century perhaps, has gone from being a series of commands and prohibitions towards something depending more on adaptive management, systems theory, and evidence-based conservation. But you're going to learn more about all this side of conservation in the other modules in this course. So let me take you back to the long picture, the long view of conservation and extinction through the legacy of Easter Island. Easter Island, which is a very impressive place, you'll see two salient features. One of these features is the statues, the great moai, which were erected by the people of Easter Island. And the other is the absence of trees. Now we know that there were trees on Easter Island. There's fossil evidence of 21 endemic species, all now extinct. All of these were lost during the spectacular but brief rise of the civilization on Easter Island. But which is going to be more enduring? Well, the statues can last for 10,000 years maybe longer, maybe shorter. But extinction is forever. Or if you take the ecological view, a niche will stay empty on average for 10 million years before it is replaced. Thus, extinction is the most enduring legacy of mankind. And for this reason, we should strenuously avoid extinction and conserve biodiversity. So here are some references and further reading that you can do if you're interested in what I've been talking about. And I leave you with a set of questions rather than the usual set of bullet points summarizing my talk. A set of questions ranging from very specific ones to very general questions about values at the end. Question 7 says, within human systems and values, why is conservation such a challenge? So, there you have it. As you learn more about the practice of conservation, you should also remember this context. Our journey in this class has shown the meaning of conservation in the light of history and of prehistory, and that the act of conservation has consequences all the way into deep time.